This is a second video in section 3.4, quadric surfaces. I forgot to mention in the first video, example 86 part B, that is a hyperboloid of one sheet. So I meant to mention that when I was doing that example and I forgot. So here we have example 87. We're looking at three surfaces and we want to identify them and sketch them. Now, here we have, this is a cone. What is our clue that this is a cone? We have a quadratic term plus a quadratic term equal to a quadratic term. Now, in the definition that I gave you, I had the x squared, the y squared, and the z squared. That cone is oriented this way, with the z-axis being its axis. But here we have the x squared term plus the y squared, or plus the z squared term is equal to the y squared term. So the axis for this cone is the y-axis. And so this is oriented differently. So we have here, if you take y as a constant, then you have an x squared, a 3x squared plus 2z squared, that's an ellipse. So whenever you take a cross section here that's perpendicular to the y-axis, you're going to get an ellipse. So we have an ellipse here, and this is a cone. Part B is also a cone, but it's a cone in disguise, because we have a quadratic minus a quadratic equal to a quadratic. So what we have to do is manipulate this equation. And so we simply add 3z squared to both sides. Now we have a quadratic term plus a quadratic term equal to a quadratic term. That is also a cone. Its axis, however, is the x-axis instead of the y-axis or the z-axis. And so if we take x as a constant, if we hold x as a constant, we have y squared plus 3z squared equal to a constant, and again we have an ellipse. So you take a cross section here perpendicular to the x-axis and you have an ellipse. But again, we have a cone.